In this world of everything connected, we need to increase the capacity of the mobile networks, but we need to improve also the energy efficiency. With this, we mean the reduction of the energy cost per transmitted bit. This reduction, apart from being interesting for telco companies, is very necessary for our planet too. For raising both spectral and energy efficiency of future 5G networks, some multi-antenna techniques like spatial modulation are being studied. In this simple modulation scheme, only one antenna is activated at distant distance. Despite of this, it allows to transmit information using also on the rest of silent antennas. The more antennas you have, the higher bit rate you can achieve at a lower energy cost. Here, information is conveyed in two different ways. One, by the selection of a symbol from a constellation, and two, by the selection of a particular antenna used to transmit its symbol. I have started my PhD studying different adaptive algorithms, whose purpose is to approach the transmission bitrate as much as possible to instantaneous channel capacity. Firstly, my research was focused on mobile satellite links, such those of Iridium and Inmarsat. But then, when dual polarization systems drew my attention, a link between my research and 5G and spatial modulation was established. Afterwards, I tried to calculate the capacity of a spatial modulation link, and here machine learning crosses my path. I found that with a shallow neural network I can calculate efficiently and with high accuracy the capacity of this scheme. This, of course, required the smart selection of neural network inputs. I chose not only the signal-to-noise ratio, but also the angles between the columns of the channel matrix, since they affect strongly to the capacity. With this neural network, adaptive systems would compute in real time the channel capacity and adapt consequently the transmission bitrate. And lastly, in my thesis, I proposed to use a deep neural network for choosing instantaneous rate in a practical spatial modulation system. Adding some additional layers and training it with data from the actual performance of a receiver, the neural network can learn to choose the optimum modulation and coding rate. And what does this mean? That while you're moving with your smartphone around the city, the speed of your internet connection could be optimized in real time, and you could get the highest speed that the channel conditions allow. Therefore, with the help of deep learning, I have developed a fully adaptive spatial modulation system, ready for being used in future 5G networks, with higher capacity for carrying all the information we want, and very efficient for not harming our planet with so many greenhouse gases each time we want to see our favorite HD video.